Hello, welcome. Glad to have you. And this is going to be a video about me. I find out how I'm talking about myself. There are individuals that really love to talk about themselves. I've seen quite a bit of that, but the main focus that I'm going to, apply when I'm talking about myself is my path, and that's in, because every student is is on a journey, some kind of journey, and my path was a little bit, a little bit back and forth. It zigged, it zagged, uh, but all the time it was moving forward in the right direction. Uh, and so this is a wonderful metaphor by hey, because by a shepherd, but I love dogs, border collies specifically, uh, little devils, and every morning a border collie, when they're ready to go to the park, they just come up and start hitting you in the face with their paws. They're crazy. They're too smart as well. They can open doors, you name it. But yeah, if you ever want to get me talking, bring up border collies, and I will go on for a little while. But my path, a little bit zigzaggy, you know, um, but overall, following, moving along in a straight line. Um, so I guess I want to talk about where my path, a good starting point was middle school. That's when I was able to choose my own classes. And my dad told me, he said, as long as you take the most difficult math class that you have available, I won't care what you get in any other class. Like, I can get C's, and he wouldn't mind as long as I passed, and I just had to pass the most difficult math class available to me. And being young and into fun, I was like, yeah, I'll take a little break on one or the other to have a little more fun. Young, when we are young. By the way, try to get better than C's, if you can. But my focus was math. It started from that point, and then I realized that, hey, even though I might not want to get C's, um, that's, as far as the focus of what was important within my family, I was happy to make the deal, and then I could do as best as I can in the other classes as long as I was passing my math. So I started middle school, hey, choosing hardest classes. Then I went up into Kamaikan, again, choosing the hardest math classes, and moving forward. And I decided, because, hey, this is, especially back then, it was really a small town. Well, yeah, it was fairly small. I mean, it's small now. People consider it small now. But my parents, my family, um, they're I'm third generation, reactor, Hanford area, a worker. My grandfather was the first generation, and of course, my parents are second generation Hanford workers, and they really did not want that for me. Uh, but when I started in Columbia Basin College, I kind of didn't know what I wanted to do. I had no clue out of high school what was my path. I was just, hey, going in one direction, go in the other direction. I started the radiation protection technology program at Columbia Basin College. It was 2 years, so I could start working out in the area. And while I was doing that, I worked full time in retail. So I began, and I worked full time ever since, high school. And I still continued working full time in retail. And, but that was my first entry into college, was here at CBC. And I was not going for a 4-year degree. I was going towards more of a career certificate type thing to work out in the area. And I wasn't for sure about that, but I still did, spend about a year and a half pursuing that at CBC as a student. But, certain things happened in life, and I decided that I wanted to go in a different direction. And that was going to be a new path. And I wanted to challenge myself because, hey, you've got all this math, knowledge. You could probably get through some of those college classes. Why don't I pick out a good 4-year program and then pick out something that's going to be needed in the future? And of course, back then, 1998 or 9, it was, or 2000, I was well, I was pretty confident. And I switched degrees to a Bachelor of Science in Computer Science because computers were the future at that time, and they kind of still are. And one of my background thought process, I was thinking while I was making my decision, but what if I don't like computers and I want to stay in computers? And I thought, well, think of a job now that does not have computers. I could go and work in any industry. I can go to work in the hospitals. I can go work in the schools. I can go work in, the government labs. There was a lot available with a Bachelor of Science in Computer Science. So I started a 4-year program at Heritage University, which is local. It's a private university. It was rather expensive, but I wanted an experience that was a little bit more. Let's say that we, in our class, we would have a PhD instructor and only about 5 students. So imagine, the breadth, how rich that learning environment was, to have that kind of course and structure, with just, definitely the ability to soak up everything that professor could bring to the table. And we did well. Well, all of us still, as we work through, have, as for part of one of the initial graduating classes for computer science at Heritage University. Everybody's done well in my whole class, or cohort, however you want to sedate that. But there's some crucial things that I learned at Heritage University, and that was learning C and C++ programming. Uh, and once you learn that particular language, you know them all, really, you do. And another thing is I learned how to build a compiler. How does that work? What is that? What happens? So I then built a rudimentary server-sided program with that was able to work on the web and get data from people to post on an email list server, one of the very early types of email list services or servers. So I was able to build my own, and during that time, I also, learned how to build my own, work with my own services like mail servers and stuff like that. And that was all, the list server, the stuff that I learned here, I still use today. Here even, I definitely use this today. So yeah, I started getting down to the end of my 4-year process, learning at Heritage University, and they came to me. It was really nice. I didn't have to even apply for it or anything. They came to me and said, "Hey, would you like an internship?" Which actually turned into employment, and that was like towards the end of my 3rd year. And I started that job, and the learning curve that I had was way more, it was very steep compared to consider this line that's maybe a normal learning curve. This one, whoop, just straight up. I learned a lot in a quick amount of time. So that internship experience was vital. And what was I doing in that internship? So the internship with spectrometers. It was a company called Berkeley Instruments. It was a umbrella underneath P&L. Battelle. Battelle really likes to help along small businesses that they kind of have influence over, and actually in most cases started. But spectrometers are, you can tell up here in this area that with the rainbow color in there, that's a spectrometer. And what it's doing is it's taking the light and measuring the different values of the light spectrum across the whole spectrum of light. And before spectrometers were able to, not before spectrometers, before this technology was built, when a packing warehouse that packs up apples needed to test for sugar content, because our fruit, if it has a good sugar content, we'll go to Japan instead of stay here or go to another or have another process added to it. But before, you had to actually destroy the apple to test how much sugar content it had in it. And so what they would do is, of course, run 1,000 apples and test one before, test another one after, destroy those apples and say, hey, the ones in the middle have this amount of sugar content. That was wasteful, and also it was timely and labor intensive. And by then, spectrometers, this one's a cardboard box, but imagine it's a line that goes to the computer. they they spectrometers were able to have the speed where they could read the light spectrum one time every 5 milliseconds. So that means that if we wanted to take this apple, put it in between the light and the spectrometer, the light would go through the apple into the spectrometer. And because fruit has sugar crystals, you could use the spectrometer to predict how much sugar was in that fruit. And spectrometers now were now able to do like, the speed that I was given when I was building the system was to get it to running 10 apples a second. So that means every second that spectrometer is going to look at 10 apples. And so the device driver that I built for the hardware had to be extremely fast. That was the goal, is how lean and mean can I get this data so that we can predict the sugar content. And I completed the software for that hardware prototype and built the device drivers, built the prediction models, all that stuff all together, so that when we looked at the values from the spectrometer, we were able to get enough data and measure the sugar content at the speed of 10 apples a second. And so it became commercially viable. Before, it was not commercially capable. I mean, Pinanel knew that the hardware was now available for this, and that branch company, Berkeley Instruments, was implementing it. And they gave me the job of writing the device drivers and getting it to the speed that it could would be viable commercially, and that was successful. It was a year and a half of heavy learning. So why are spectrometers important? I kind of talked about that already a little bit, but I want to kind of go into that. We don't get the best apples. That because this is just a little nitpick. Japan will get the best apples, and they'll spend $20 on fruit. So if you're spending $20 on a piece of fruit, you want to know that it's perfect. And part of that journey of building the software for that spectrometer is I needed to know what matrix math was, linear algebra, and totally take advantage of all the math that I had ever sponged up through my time in education. Well, I never left, actually. Well, sort of, for about a year or so, but because I'm in education still. So that was successful, and the company sold the technology, the licensing, to a prominent apple packing machinery provider called Awida, and they build a lot of the machines that the packing houses use. So they had a significant interest in being able to add to their machines a prototype device that measures the sugar content of every apple that it passes through. And they bought it up for, I think, $500,000 or something like that. And the company since they had a winning, part of the winning uh, licensing, they were, they ended up being successfully off the. They didn't really need people anymore for development, and they decided to kind of shut doors and move on with just the patent and go from there. Since the other companies that bought the licensing would be developing the actual device that we gave them a proof of concept of, developed all the documentation for, and then they, the packing house, the company was in Germany. They got they purchased and licensed the tech, and so this is what they look like today. And there's a spectrometer for every one of those Apple lines, and they go in, a light is shown on it, and then the spectrometer reads the light that was shown, that was, going through the apple, or, that essentially when the apple, the light here, the spectrometer, the apple here, light shines that way, spectrometer gets the actual reading. So a lot of those apples were getting pretty glowy. When they use special lights so that the whole apple would glow, and that's why you see this kind of contained, because the lights they use they cause a lot of heat, and if the packing house were to stop and the light was still shining on the apple, it would eventually burn it. So that shroud is to protect people from the light that's going through the apple that's being read by the spectrometer. It's kind of cool to see stuff industrial, being used industrial, in the industry, that you built a prototype, or when I didn't build the hardware, I did all the software, and it was a whole system. It was about 90,000 lines of code. It wasn't low. It was a lot of code, and I had to build my own matrix library, lots of different things that had to become custom, a custom device driver to ensure that it was fast, and then even some assembly language to get the data off the spectrometer as fast as possible. So I continued and graduated. Kind of, the company went away and I graduated at about the same time. So one thing that I kind of enjoy is to build things. I like to build tools, and I have a workshop, that that is pretty significant when it comes to machinery, just for fun. It's a good way. If you're going into computers, there's going to be a point where you're going to need to be away from the computer as much as possible, because it's just more work. Get away from it. Have some fun. And I graduated and was like, on a lark, I sent in a resume to Columbia Basin College for a C++ instructor, and they accepted me. So I started teaching night school as an adjunct faculty back in 2002. But the teaching bug had hit, and I liked staying. I wanted to stay in the Tri-Cities. So it wasn't like I could head over to Seattle and go work for Microsoft, or because I just didn't, that didn't interest me. And at the same time, my time beginning at CBC really changed my outlook on where my path was going to be. And so this was where I did a zig and a zag. Um, I found that I enjoy teaching, and I then enrolled into another degree while I was teaching at CBC. And because I was teaching at CBC and Heritage is using CBC facilities, I was able to get that degree and not have to pay for it. It was a special deal that CBC and Heritage did. As long as, Heritage, well, okay. It was kind of nice. So I went into a whole new group, a whole different way of thinking, because this is now an area where most bachelors of arts go into. And, I have a Bachelor of Science background, and I'm kind of switching focus into people problems, working with people. Before, I realized that, hey, I like this. I don't necessarily care to be just on a computer all the time in the back in the closet building things. There's other ways to build. And I was doing good for that whole year and a half working on that master's, to the point where I got a job working at a middle school. I got a certificate. I got a job working at middle school, and I'm still teaching at CBC. And I'll tell you what, if you, middle schoolers are crazy. They just are. I kind of just think of them as insane. uh, they're a little bit nutty and quirky. That I did that for 10 years. I taught at middle school and I taught at CBC for 10 years, 2 jobs. And CBC I would do 2 times a week at night. And I'll tell you what, learning how to be a decent, halfway decent middle school teacher, and working within that Bachelor of Arts focus type of people was difficult for me. My challenge was working with people. Computers, nah, no big deal. I can do it, whatever you want. I saw it as kind of also, as something that I needed to work on personally. There are all kinds of computer scientists out there that have spent more time in front of computers than ever in front of somebody else or around somebody else. So yeah, I had 2 jobs. Did it for a while, and eventually, or as years progressed, I got much better at my job and much better at working with people. It became almost second nature. I still get some butterflies, being an introvert. My first lecture, oh my God, it was cringy. I was so nervous. Whatever it is that makes people want to cringe, chalkboard and nail or whatever. It was a travesty, but it only happened on the first one. And after that, it was, it was great. So, 100% of everything that was important and has served me well in my career was because of that internship. it gave me job experience. It gave me my first initial employment and my first success before I decided to go become a teacher. So yeah, graduated, and within a month, I'm working at CBC. So the difference in the difference in my, what I was able to consider as soon as I got a degree, what I was able to consider for a job widened quite significantly with every, I've got 2 degrees, widened. My ability to find a job, a place that would take me, every time I got a degree, it just widened. And I'll tell you what, I got paid, I worked 40 hours a week, and then I started working at CBC, and I'd make the same amount of money working 9 hours a week. That's a no-brainer. So yeah, I did that while I continued my schooling, and it worked out well. So then we kind of get into another kind of zig, but not too much of a zag. After 10 years of teaching middle school, I had finished my professional teaching certification. I've shown that I'm a master of my craft. My pedagogy was at a point where I was not challenged anymore. I really wasn't. My classroom management was excellent. My ability to interact with people, excellent. And CBC said, hey, we've been having you for 10 years as our adjunct. Now, this time, would you like to apply when we asked you, or when we ask you? Because they had asked me to apply for a full-time position 10 years previous, and I wanted to go teach middle school because it was challenging. And I was like, okay, no, I'm going to go do this for a while. I had, during that Master of Teaching degree, I had bonded with people in my cohort who also had the drive to become a teacher. I wanted to have that experience. So I didn't apply when they asked me to apply. After I got, when was it? Jeez. 2000, okay, never mind. But they asked again. They said, hey, please apply for this. Because they've known me for 10 years. They know how well I can handle the classes and how well I work with people. And this time I was ready. I applied. And I came out as the top, one of the top leaders, because they actually hired 2 of us at the same time from the pool of applicants. So I'm full-time at CBC. I mostly teach, programming classes. That's predominantly my specialty. And also cybersecurity. Because, hey, I was trained how to build the tools that cybersecurity analysts are trying to protect. But, an interesting thing on that is I always had this a bad perception, because I was thinking, oh, I know how to build the tools, so I know how to protect them. I know how to secure the tools that I build. No, cybersecurity, a whole nother field. I didn't, when I got out there, now that it's its own, field, and it's much more different than what a Bachelor of Science would be expected to be doing. And it's exciting, to see some of the stuff out there that, and learn about cybersecurity. It is incredible. But yeah, I teach server-sided programming, JavaScript, Python, C++, C, Java, C Sharp. You name the language, I teach it. Because I started with C and C++. So any language that I need to pick up is easy. It's a cakewalk. So once you learn one, Python is just a low-level C and C++. But once you learn one, and it doesn't matter which one people learn, they're going to be much more able to adapt to another language in their career. So keep that in mind. I'm kind of prone to my C and C++ ways. I'm pretty good at JavaScript. I'm pretty good at PHP. C Sharp. I'm very good at C Sharp. And then of course, I can hold my own. I'm in Java. Java and C Sharp are actually the same thing. They use different words, of course, but it's all built on the same type of technology of dynamic binding with objects. It's kind of cool. So, what do I like to do? I like to build hammers. Yeah. Spend time with family, build hammers, throw a frisbee for my dogs. By the way, border collies, when they catch a frisbee, oh my God, they go up in the air like it's beautiful to watch them in the park. Everybody knows the names of my babies because they go out and give a show almost every day. They definitely can catch those frisbees with flair. And unlike some I keep making them. I've got a lot now. I've got a lot of these hammers, and they're titanium. Yes, I make titanium hammers. I like to make different things out of titanium for fun, and I weld it. And so I've got a workshop that has a lathe, a big lathe. There's another one. These are not my best work. I've got some better work than these. But yeah, that's me. Come in and visit me. I'm available during office hours. Work with me in the lab during those office hours. I call them tutoring office hours. But yeah, don't be afraid. I'm a really nice guy. In fact, I enjoy it when students come face to face. So yeah, bye-bye.